Good morning. Today we're going to be learning about combining like terms, but before we do all that, there's a couple of definitions that we need to get. And those definitions are term, variable, coefficient, constant, and like term. So let's start off with the term definition. So a term is a number, variable, which is just another word for letter, and you're going to see that in a second. Product, or quotient, of a number or variable that are added or subtracted in an algebraic expression. And an example would be just an example of an expression would be 2x minus 4y plus 7z plus 3. So a number can be a variable. 3 is a 3, not a variable. 3 is a term because it can be a term as a number. It could be a variable, we don't have a single variable here, but it could be the product of a variable and a number, because 2x is a multiplication problem, 4y is one of those, and 7z is also another term. A variable is a letter or symbol that represents a quantity that can change. So basically for us, a variable is just going to be a letter this year. An example might be X, Y, or Z. And when I make my Z's, I put a line through it so it doesn't look like a 2. A coefficient is a number next to a variable. And that is just in layman's terms, but that means the number is next to a variable, which means it's going to be a multiplication problem. An example would be, for instance, if we had 2x or 1/2 y. The coefficients would be the 2 and the 1/2. A constant is a term that does not change does not have a variable. For instance, this might be, sorry, I got the wrong thing here. So you had 3x plus 3. The constant in this case is the 3 because there's no variable next to it. And that can't change. 3 is always going to be 3. Like terms, last definition here, terms that have the same variable and same exponent. We won't be doing much with the exponents this year, but next year you will definitely have like terms with exponents. So let's go to the next page here, which will get into some examples about how to combine like terms. So when you're combining like terms, you need to find things that have the same variable. If they don't have a variable, they're also like terms. Now, there's something important here that you need to know. I always, you can color code these things, you can shape it however you want, but what I do is I use circles and squares and different shapes. So, for instance, I'm looking at example 1 right now, and I know that 3 has an x with it. So the coefficient is 3, the variable is x, and I'm going to look for anything else that has that same thing, a number and an x. Well, in this case, I see that 2x is also there, but I'm going to also circle that plus sign so that I know that 2x is positive. So now you always add like terms. So in this case, 3x plus 2x is 5x, and we would be done. In the next one, I see that I have a 7x. I'm going to circle that. I look for anything else that has an x, and I have that, and I also circle the positive sign in front. So now I add those. 7x plus positive 2x gives me 9x. In example 3, now I'm going to start to see that I have more like terms than just a pair. So if you take notice in the first 2 examples, everything in the equation, the expression is circled. So there's not a sign that's not circled, there's not a number, there's not a variable that's not circled or in some kind of shape. So in this expression, in example 3, we're going to have more than one shape. So I'm going to look for anything that has an m first. So I found 5m. I found negative 2m. And the reason I circled them is they both have an m, and that subtraction sign, some people say it's a subtraction sign, but it's also a negative sign, goes with the 2. And then negative 3m is also like term with those 2. Now, I'm going to change colors, and because the 8 and the 6 are constants, they have no variables, they are also like terms, I am going to box those with their sign before it. So I have a positive 8 and a positive 6. That means I'm going to add the same shapes or the same colors. So 8 plus 6 is 14, and that's positive 14. So I'm going to add 14. I'm going to add the other numbers. So 5 plus negative 2 would be 3. 3 minus 3, or 3 plus negative 3, is going to give me 0. So the answer to this one is just positive 14. You could also just write 0m, but we don't usually ever write that because 0 times m is 0. So the true answer to this is just positive 14. Okay, let's go to example 4. Again, I'm going to look for like terms. So I'm going to circle 7a because it has an a. The plus sign with the 4a gets circled. And now I'm going to change colors. And I have a b here, so I'm going to put that in a box. And I have nothing else that has a b, but now I'm going to change colors again. And I'm going to put 5 in a triangle because 5 is the only constant. So the only two like terms that I have to combine here are 7a plus 4a, which is 11a. And then I just bring down all the other like the other ones because they have no like terms. So the answer to this one is 7a plus 3b plus 5, because I could not combine anything else that is like terms. Next example. I'm going to find anything that has an x. So I have 6x. Then I have negative x. I'm going to box those. It doesn't matter what shapes you use or colors. I'm going to circle positive 4y. And again, positive 4y. I'm going to add my y's first. So 4y plus 4y gives me 8y. And then I'm going to add 6x plus negative x. Now, here's something that you need to really pay attention to. Whenever you see just a variable x or negative x, so in this case there's no number between the x and the negative sign, there is a 1 there. Always there, just usually not written. So now if we do 6x plus negative 1x, we will get 5x, and we put a plus sign between those because the 8y is positive. So the simplified combining like terms expression for number 5 is 5x plus 8y. Over the next 3 days, you will be utilizing this method. You can use shapes, you could use colors, however you need to do it. So if I was using colors, it might look like this for the last one. So I would highlight the 6x, highlight that in one color, highlight that in another color. But if you take notice, nothing is left out of the expression. Everything in the expression is either in a shape or in a color.